So this time we have one more step to solve for before we can solve by elimination. If you look at our second equation, it's not in standard form like we're used to seeing, like our first equation is. So this time the first thing we need to do is reorganize our equations. So we have both variables on one side of the equal sign, and our constant, or the number that's all by itself with no variable, is on the other. So looking at my first equation, it's already organized nicely, so I'm just going to rewrite it. And my second equation, I just need to move my 3y so that it's over on the same side as my 4x. And we get 4x plus 3y equals 7. So now when I'm deciding on a variable to eliminate, they both have the exact same coefficients, 3 and 4. So I can choose either one. I think I'm going to go ahead and eliminate my y's. We'll determine the least common multiple of 3 and 4 is 12. So when I multiply my equations, I need to make sure one of my y's has a coefficient of positive 12 and the other one has a coefficient of negative 12. So I'm just going to multiply my first equation by, we'll do a negative 3, and my second equation we'll do a positive 4. Distributing my negative 3, I get negative 9x minus 12y. Negative 3 times 14 is negative 42. Distributing my 4, I get 16x plus 12y. 4 times 7 gives me 28. Combining my equations, 16x minus 9x is 7x. Negative 12y plus 12y cancels, and 42 minus 28 is 14. Negative 42 plus 28 is negative 14. So dividing both sides by 7, we get x equals negative 2. So now I need to follow my last step down here, which is to finish solving. I need to solve for y. And I have to go back to one of my original equations to solve for y. And I think I'm going to use my first one because the y doesn't have a negative coefficient. So when I substitute negative 2 for x, I get negative 6 plus 4y equals 14. Adding 6 to both sides, I get 4y equals 20. And finally, dividing both sides by 4, I get y equals 5. So my solution as an ordered pair, my x was negative 2 and my y was positive 5. So to check that in the equation that I didn't use to solve for y, that would be this second one. So we get 4, substituting negative 2 for x, equals 7 minus 3, substitute 5 for y. 4 times negative 2 is negative 8. 3 times 5 is 15. And 7 minus 15 is negative 8, so my solution checks out. Let's take a look at one more of those. Again, we need to rearrange our equations so both variables are on one side and our constant is on the other. So in this case, both of my variables need to be rearranged. My first equation, I'm going to subtract 3y from both sides. So we have 8x minus 3y equals 4. And my second equation, I'm going to add 5y to both sides. So we have 5x plus 5y equals negative 25. So when I'm trying to eliminate a variable, I've got, for my x's, my coefficients are 8 and 5, and for my y's, they're 3 and 5. So I'm going to go ahead and eliminate my y's again, because they have smaller numbers than my x coefficients. So 3 and 5 both go into 15. And this one's nice because they already have opposite signs, so I get to multiply by positive numbers this time. So to get 3 to multiply to 15, I'm going to multiply my first equation by 5. And my second equation, I'm going to do 5 times 3. First equation, distributing my 5, I get 40x. 5 times negative 3y is negative 15y. and 5 times 4 is 20. Second equation, distributing my 3, I get 15x plus 15y. And distributing my 3 to the negative 25, I get negative 75. Adding my equations together, 40x plus 15x gives me a 55x. My y's cancel, and negative 75 plus 20 is negative 55. So when I divide both sides by 55, I get x equals negative 1. So now I need to use one of my original equations to solve for y. And y isn't really alone on either of them. I'm going to use my first one because we've got positive coefficients, so it'll be a little bit easier to solve for y. So I'm going to go ahead and substitute negative 1 for x. 8 times negative 1 is negative 8. Subtracting 4 from both sides, we get negative 12 equals 3y. And dividing both sides by 3, we get negative 4 equals y. So my ordered pair solution is my x-coordinate is negative 1, y-coordinate is negative 4. Last step is checking it in the second equation, the one that I didn't use to solve for y. Substituting negative 1 for x, does that equal a negative 5? Substituting negative 4 for y, minus 25. Sorry, running out of room here. So giving myself a little more room, I'm going to come down here. 5 times negative 1 is negative 5. Negative 5 times negative 4 is positive 20 minus the 25. And 20 minus 25 is negative 5, so my solution checks out.